Alright guys, lesson 6, using sine, cosine, and tan to actually find the length of sides. This is kind of like what the point is of all this, is to actually use sine, cosine, and tan to figure out missing sides on triangles. Okay, so this is where it all kind of comes together. We're just going to do 3 examples to show you how this works. Alright, on your examples it'll be pretty specific about how to draw them. It'll say draw it, angle C is the right angle. It will say A and B are the acute angles, so you can just draw it like this. It'll give you something like it will say angle A is 40 degrees, and then it will say side BC is 6. I'm sorry, side AB is 6, and then it will say find the length of side BC. So I'll call that X. Alright, so that's how the directions will be. It'll say angle A is 40, side AB is 6. 6, angle A equals 40 degrees. Side BC, find it. Okay, that's the setup. Alright, so we're trying to find a side. Okay, this is how you can set it up. We're going to either do the sine, cosine, or tan of the angle. So I'm going to go like this. I got to decide sine, cosine, or tan. That will go there, equals, and then I'm going to have something here divided by something here, the ratio. Okay? So how do you decide sine, cosine, or tan? Well, we're going from 40. This is opposite and hypotenuse. Okay, so look back at your definitions. You might want to just jot these down. Sine is opposite over hypotenuse. Cosine was adjacent over hypotenuse, and tan was opposite over adjacent. So I got to decide which one to use. Well, if I'm talking opposite here and hypotenuse, I want to use the one that has opposite and hypotenuse. And I know the hypotenuse, I'm looking for the opposite. So I want to use one that involves opposite and hypotenuse. I don't care about adjacent. I'm not worried about adjacent. So which one has opposite and hypotenuse in it? Right here, sine. It's only one. Okay, so that's how I know I need to put sine here. Okay, what do you put here? Well, I put the opposite and hypotenuse. So opposite is the X. That's what I'm trying to find. Hypotenuse is 6. Alright, that's a setup. Now we got to actually solve this. So how do you solve it? You use your trig table. So go to your trig table. I got to look up sine 40 degrees like what we did on our last lesson. Sine 40 degrees. Here's 40 degrees. Sine. Right here, 0.6428, if you can read that. So I'm going to say 0.6428. I just looked it up in a table. Bring it down, equals x over 6. Alright, I just looked this ratio up in a table, like what you did on the last lesson. This whole thing turns into this decimal. Alright, we're using a calculator here. So x is going to equal 0.6428 times 6. Right? If I multiply, I'm not going to show that here. I just don't want to make it too messy for the people that see this work, but it's times each side by 6. Okay, I can put it real lightly, times 6. Okay? So let's multiply that out on the calculator. 0.6428 times 6, 3.8. I mean, you can go to 2 decimal places is fine on that answer. 3.86. I would go 4 decimal places here always, but for your final answer, if you want to go 2 decimal places, that's fine. That's x. Okay? That's how long that side is right here. Alright, so kind of a cool way to figure out the side. We couldn't use Pythagorean theorem because we didn't have 2 sides to work with. It's a different way of finding the sides. Alright, let's do another example. It'll be kind of similar. It'll say angle A is 40 again. A and B, it'll say are the acute angles. C is the right angle. A is 40. It'll say AC is 10. And it will say find the length of AB. So I'll put an X there. So there's always one side to give you, one side you're trying to find. Okay, first off, same thing. We're going to do this. I'm going to put the angle right here so I know what angle I'm dealing with. And then over here I got to put in the ratio. All right, so what am I dealing with? Sine, cosine, or tan? From 40. Adjacent, hypotenuse. Right? Adjacent, hypotenuse. Look here. Which one of these has adjacent and hypotenuse in it? Only one of them does. Right there. Okay, so we got to use a cos. How did I know that? Because I knew we were dealing with adjacent and hypotenuse. I'm not worried about this. There's nothing here. There's no x here. There's no number here. I'm only worried about finding this one. And I know this one, so I'm dealing with the adjacent side and the hypotenuse. That's the main question people have. How do you know what to put there? Well, I'm trying to find the hypotenuse. I know the adjacent. That's the two I'm dealing with. Right there, cos. All right, cos 40. It equals adjacent over hypotenuse, so that means the 10 goes on top this time. That's the adjacent. And the hypotenuse is the x. All right, that's a setup. Next step is look up cos 40 in your trig table. Go down to 40 degrees, sine here, cos here, 0.7660 equals 10 over x. Okay, to solve this, I'm going to just go down here and show you the steps for solving this. Because you say, oh, I'll multiply by 10. No. Okay, the 10's in the top. We need to get the x up in the top. Multiply each side by x. Okay, 0.7660 x equals, these x's cancel, 10. Now the x is in top. Now I can solve for it. Divide each side by 0.7660. All right, boom, cancels out. Now we've got our answer. X equals 10 divided by 0.7660. Okay, I get 13.05. We can just go 2 decimal places on that answer. That's fine. That's the answer. Okay. Notice that time x was in the bottom, so it was a little bit different solving. This one up here, x was in the top, so it was a little easier to solve. It was just multiply. Okay, let's do one more. If you feel like you got it, you maybe don't even have to see this third example. I'll just give you a third one. It'll say angle A is 70 degrees. Try to draw them kind of to scale. That's pretty bad, but 70 for angle A. It'll say AC is 10. Find, this is B up here. Always just set them up like this for now, guys. Be easy. Put the A there, the B there, and the C there, and it will work out for you. And it'll say find BC. Okay. I would recommend you always just write this out like this. What do we get put there? Sine, cosine, or tan equals blank over blank. If you do that, you'll get it. Okay, we're dealing with opposite. We're trying to find opposite, right, from 70. We know the adjacent. So which one uses opposite and adjacent? Look through here. Just that one, tan. All right. So tan goes here because I want to deal with opposite and adjacent. And then what goes here? Opposite over the adjacent, right? It's the definition. Opposite is x. The adjacent is 10. All right. Look up tan 70 in the table. It's over here in the second column. Sine, cosine, tan, 0.27475. Write that whole thing down so that we get an accurate answer. Equals x over 10. Okay, solve this. I'm just going to rewrite it. 7.4. You don't have to necessarily rewrite it. I'm just trying to make it clear for the people that see this paper later. Okay, how do you solve this? Times each side by 10. Okay, which times by 10, move the decimal over 1. 27.48, right? If I round that 7 up, equals x. Okay? Make sure that answer makes sense. I mean, if this is 10 and this is 27, would that make sense? Well, it would if I would have drawn it more to scale, because this 70 would have been a steeper angle. This side should have been a lot longer, actually, if I would have drawn it to scale. Okay, so that answer does make sense to me, because I know this side should be longer than this side. If it was 45 degrees, these would be 1. So the question here's a little bonus. If you listen to this whole video, you get this: why is tan of 45 equals 1? Well, it's because tan equals opposite over adjacent, and opposite and adjacent are the same when dealing with 45 degrees. Okay, in other words, 45, 90 triangle, 45, 45, 90, these two sides are the same. So if I divide them, it's going to equal 1. All right. Oops.